Today, we're going to be talking about rapid prototyping, which some folks define as the creation of a model that will eventually be discarded rather than becoming part of the final delivered software. But as many of you who have worked in software probably know, things that we think shouldn't end up in production very often end up in production. So I think it makes more sense to define it as taking an idea and getting it to an MVP as efficiently, economically, and effectively as possible. So to me, rapid prototyping isn't something that you're just going to throw away completely. It's something you're hoping to refactor and polish and maybe use again. And today we're specifically going to be talking about rapid prototyping AI applications while using some AI tools, and specifically some tools that you can run locally for free. Even on a MacBook Pro from 2012 that is stuck on macOS 10.15. And apologies in advance for the low quality of some of these demo clips. This poor little laptop was just burning up trying to run some of this stuff and also record the screen at the same time. Hey there, my name is Eric. I'm a developer advocate at Datadog, and I've been having a lot of fun in the AI space lately. That's the AI version of Bits, our logo, by the way. I love my doggo, Judge, and my fiance, Priyanka. We love to travel, and I love to cook. And I also love board games and tabletop role playing games like Dungeons and Dragons. So I thought it'd be fun to prototype an AI app aimed at helping dungeon masters refer to rules, sling some dice, quickly describe events, and name places, people, things, and whatever else you might need to end up naming while running a campaign. And we're going to run through a few layers of the stack here and discuss things you can run locally for free to prototype similar applications. Beyond a basic chat UI, we'll also have a serverless function that accepts our prompts and can stream back responses to that UI. We'll have a locally running vector database that we can use to augment our bot with information from the real world. In this case, we'll be looking things up in the 5th edition Systems Reference Document, or SRD for short, which is sort of like the open source core rules for D&D 5th edition. And then we'll also have a quantized large language model running locally and responding to our prompts using a retrieval augmented generation, or RAG, strategy powered by that vector database. And because I want to make sure that you know that anyone can do this, I'm going to be avoiding the most popular language for AI applications, Python, and doing the whole thing in TypeScript. The JavaScript ecosystem is definitely lagged behind Python in terms of the AI space, but it's still incredibly easy to spin up an AI application locally and validate your ideas. A couple of quick disclaimers so nobody gets too mad at me while you watch this. I am not an AI expert. I'm just a dude with a lot of curiosity, probably too much time, and I like to play around with stuff. I will be simplifying things. I don't think a deep understanding is necessary for what we're talking about today, so I've simplified some stuff to make it easier to talk about and hopefully more enjoyable to listen to. I might anthropomorphize. I know logically that these language models are just programs doing what programs do, but sometimes what they can do is pretty interesting. And the last one, I had to speed up some of these recordings because a machine this old can be really slow to generate some of this output. And I've got a very limited amount of time to talk to you today, so I can't wait for it to actually take the full amount of time. If you were running the same stack on a modern MacBook Pro, it will be impressively fast, I promise you. Now that that's all out of the way, let's get into the fun stuff and take a look at some of the tools that we're going to use today to quickly scaffold, iterate, and develop our prototypes. The first tool we're going to talk about is Olama, which is a really, really cool service that lets you install, modify, and run large language models on your local machine. And you define them in a syntax kind of like this, which looks a lot like a Docker file. And that allows you to modify and create your own version of a model with its own system prompt. And then you can chat with it, all on your local machine without sending out anything to any third-party servers. That brings us to the first rapid prototyping tip that I have for you. Actually, that's a mouthful, so let's just call them prototypes. There are so many models out there, like seriously a staggering amount of them, and not every model is suited to every task. You might find the general purpose model gives you a good enough idea for your prototype, but if you're focused on something like code generation, you might want to explore the code specific models. These local models, especially the heavily quantized ones, might need some serious tweaking to the system prompt and settings like temperature, which dictates how creative the model is, to get them to respond correctly. You will need to play around with this. And here's a tip if you're on low-powered hardware, which I guess I'm going to call a low tip. The 7 billion parameter V3 of Orca Mini, which is based on Llama 2, works surprisingly well on low-powered devices. Everything you've seen on my 2012 MacBook Pro there has been powered by Orca Mini 7B V3. Two other tools we'll make use of here are the Versal AI SDK and LangChain. Versal's AI SDK is going to help us have a nice streaming UI for our chat interface. Integrates really well with React, Next.js, things like that. And then LangChain is going to help us with actually retrieving information from our vector database. And in our case, that vector database is going to be Chroma, which is an open source vector database that you can run in a Docker container locally. And let's quickly just talk about how a vector database works and how this sort of retrieval augmented setup we're going to use works in practice. We'll start with our document, which is Markdown, and this one is a representation of the Goblin stat block. And that document gets broken down into manageable chunks that we're able to convert into vectors and then store in our database. And they look something like this. And those get broken into tokens, like this. And tokens get converted into IDs, which is how the model internally understands what different words are. And you end up with a big array of a bunch of those chunks broken down into tokens. And then each of those tokens gets broken down into vectors, and that is what we're going to end up storing in our database, along with the document content and some metadata about where this information came from. So when your user comes by to ask a question, like how many hit points do goblins have, that gets broken into tokens, which get turned into their IDs and then vectorized. Then your database query compares those to the vectors already stored in the database and returns any documents that have the right amount of overlap based on different algorithms that are way outside the realm of my understanding. And then you can take the content from those and inject them into your system prompt, and that's retrieval augmented generation in a nutshell. That brings us to our next proto tip. You don't need to load up every possible document and generate embeddings for it. Just pipe in a few and test against those for a general idea of how things will work. You'll probably want to work on some more advanced and logical chunking strategies for production anyway, and you'll just waste a bunch of time generating embeddings that you're probably going to throw away. Which also gives us another low tip. Just load in 1 or 2 very short documents if you're on low-powered stuff. It can take a really long time to generate embeddings on low-powered hardware. And also, super low tip, don't try to run your VectorDB's Docker container to insert the embeddings directly after you generate them. Just write them out to disk and do that part later, because if both of those are running at the same time, your computer will have a very bad day. Now, you might have seen bots that can do all sorts of fun stuff like make API requests. And that's generally considered a function in the OpenAI world, or plugin if you're using ChatGPT's UI, or a tool if you're in the LangChain ecosystem. And if you're running a pretty large, capable model, that's definitely how you should approach it. But if you're rapid prototyping on old hardware, like this, you should just fake it. Wire up some magic command that tells your chat endpoint to execute your function, and then you can hook that up to a real tool or function or whatever the system you're in happens to be calling it at the time. Your more advanced model can actually call later. And that's what I did with the dice rolling mechanic here. Here's another proto tip. If you have a tiny local model or one that just doesn't seem to want to handle function calling like one of the OpenAI models, just sidestep the issue and hack in your own handling of it with some magic string prefix. In my experience, defining function calls and tools, you'll need to spend a good bit of time refining your prompt and function description just to make sure the model even uses them correctly. And if this thing is worth pursuing, you can just wire up the same function that your magic string invokes to the model's function calling when it's time to move beyond your local environment. You can find all the code powering this bot, which I called Gygax AI, in the GitHub repo at this URL. The QR code will take you there too, and I'll give you just a few seconds in case you want to scan it. Before I let you go, I'd love to introduce you to one more thing. Actually, scratch that. 2 more things. The first is called Open Interpreter, and it lives in your terminal where it can write and execute code, help you run scripts, and call those programs with weird arguments that you always forget. I'm looking at you, tar, ffmpeg, and git. It's even capable of doing something that I've never felt very good at, data analysis. You can have it generate data frames and give you code to inject into your Jupyter notebooks, and there's even some experimental support in a PR for running it in notebooks directly. I use it to generate and run little scripts and scaffold out projects all the time. And the last 2 I'd like to leave you with is a bit of a plug for an open source project that I created. If you're an Obsidian user, that's a Markdown note-taking app, and you've ever wanted the ability to search, tag, and archive your chats, as well as test out other system prompts, forget responses, try out rewording your prompts, or hot swap models in the middle of your conversation, my AI research assistant tool for Obsidian lets you do all of that and a little bit more. Here's a QR code and short link that will take you to the GitHub repo. You can also find it in the Obsidian plugin directory. Thank you so much for your time,